Okay, good afternoon, everyone. Thank you for coming today. Today we will be talking about how to use Git to collaborate in development of your programs and how to use GitHub as the collaboration platform. So our meeting is a small group, so it's kind of informal. If you have any questions, please ask either through the chat or, well, you can even unmute yourself if you think it's urgent enough, and you ask your question. So I will either answer immediately, or I will be delaying my answer. And if it is something which we can discuss a little bit later, or I can say that, well, it is advanced information, because of course we cannot cover all, nooks and crannies and crooks and nooks of GitHub and Git in one lecture. So today there will be two parts with, if time permits, a short break in between. And first part is collaboration, and the second is recovering from mishaps. They are related because some of the mishaps are related to collaborative development. Okay, I think without further ado, I can start. Yeah, one more thing. So it is live in the sense that there is a notebook, like Jupyter notebook, where I will be entering comments and we will see the results of them live. So last mishaps might happen. I apologize in advance for that. Also, of course, everything was checked, but certain inputs give slightly different behavior. So sometimes I can go like, oops. Okay, so this is how we deal with that. It will be educational experience. So, second thing, that if you like to follow like behind or ahead, there will be right now shown a link, I can copy it to the chat, where the slides are available, generated from this notebook. Also, I should note that the material presentation is optimized for the notebook and not for HTML slides. So slides are a little bit, how to say that properly. They're not as quality of a live notebook presentation. And of course, the recording will be available later if you want to listen it again. Okay, so let me start sharing my screen. Do you see my screen? Okay, good. So this is where slides can be found. I can now send it to chat. And we are talking about part 4 and part 5 and those slides. Also, again, those slides are right now a little bit behind current content because I changed something last month. Here I am doing some housekeeping. And we start with a short recap. What are we talking about? What is Git and how to work with it? So Git is a distributed version control system. What is version control system? It is something to prevent the appearance of the following, story in the file names. This is close up of this. It's from PhD Comics. So what it prevents? It prevents you from necessity to save the change in your file as a new file. And instead, you have snapshots of how you work, and this work is saved in version control system for future reference. Useful analogy, it is those revisions allow us to go back in time. What was my status of my workplace 2 days ago, year ago, 5 minutes ago? You can change something in the past. As we all know from science fiction, it creates an alternative timeline. In terms of version control system, is a branch. So after that, when you change something in the past, you continue changing, for example, in this branch. But sooner or later, you will have to merge the main timeline and your branch. It may result in, well, time travel paradoxes, aka contradictions. And in terms of Git, it's called conflict resolution. So when you merge branches, you might see conflicts, and conflicts must be resolved. Again, everything was discussed in our previous workshop, so I don't go there into details. Today, we might need to do conflict resolution. We will see. It is one of those small variations of the presentation. So Git specifically has branching fast and efficiently, and merging is easy. Which is important for our presentation is that branches can exist either on the same computer in your own repository or can exist on some other computer, for example, somewhere in the cloud. Git is designed in such a way that most operations are local, and it has, as far as I know, exactly 3 operations which work through the network. The ideology here that network is slow and expensive and disk space is cheap. Yeah, and changes is the unit of workflow, and therefore changes can be in several files, a single change, or one file can contain several changes. When you work on it, you branch, modify, commit, merge, roughly speaking. So history is forever, so which is actually helpful with recovering from mishaps. Once content is recorded by Git, it stays forever in the repository, but history can be quote-unquote rewritten. Actually, it's create alternative timeline. So in fact, history is not rewritten, just alternative timeline is created. But dead-end histories eventually will be forgotten, garbage collected. We will see it also today. So remember that when you work with Git, you have 3 areas. It is repository. It is where the revisions are kept. It is staging area. It is like the place where you accumulate changes before committing them. And work area, it is where your actually files are and where you work. So every particular file in your work area can be either tracked by Git or not. And if file is tracked, it can be unmodified with respect to the previous commit. It can be modified if you edited it. And once you modify the file, you have to stage it before you are able to commit. Now, if the file is modified and you tell Git to remove it, it becomes untracked and optionally physically removed from the disk. So one should keep in mind working with Git that staging the file and committing the file are 2 different operations. Also, there are shortcuts which allows to do it in one shot, one go. Okay, and I will tell the word commit today a lot. So a commit is a snapshot, again, simplifying slightly, is a snapshot of your working directory, or is a tracking file of your working directory. Each commit has information of what is there in that commit, who is the author, who is the committer, which, by the way, not necessarily the same, the message related to the commit, and a link, a reference to the previous commit, to its ancestor. So commit references back. So commit, this commit was first, commit B was second, commit C was the third. Fun fact, similar structure, actually this very structure is known as a variant of Merkle tree. And if you heard about blockchain, and who didn't nowadays, blockchain, it is basically a kind of also a Merkle tree. So say Bitcoin and Git share the same technology. As a side note, the tricky thing about cryptocurrency is not Merkle tree, not the blockchain. It is how to make sure that this blockchain can be changed consistently. But Git doesn't have this problem, so Git is much simpler and cheaper than cryptocurrency. Okay, so about a couple of words about branching. So the master branch, it is something which created automatically once you create a repository. Okay, I apologize if there is any disruption. My cat came into the room and it was unexpected. Sorry. Okay, anyway. So the master branch is created automatically, but nowadays there is a push to call it main rather than master. Neither main nor master doesn't have any significance to Git. It is just how to name the first branch you ever created. You can always rename it to something else. For example, this particular slides are created in the branch draft, and it's, draft forever. So it's basically my main branch. It's called draft. So branches are simply pointers to commits. Head, it is a pointer to a pointer, usually. So head always points to the branch which considered current. And new branches are created usually and easily using Git branch. For example, here we have chain of commits, 2 branches, master and testing. They point to the same commit. And the current branch is master, because head points to the master branch. If you check out testing branch using Git checkout testing, all Git does, it just says, okay, so now head points to testing branch. Nothing else changed. Now, opposite to branching is merging. Suppose you have 2 branches, master branch, which points to commit C2, and hotfix branch, which points to commit C4. When you check out master branch and then merge branch hotfix, what Git does is simply moves pointer to the master branch to the same commit as hotfix branch. It is so-called fast-forward merge. It's effortless and very simple. Sometimes, though, the branch which you want to merge is not your direct ancestor. Or is, let's put it, not your direct descendant. Excuse me. So not direct descendant. So the current branch is not a direct ancestor of the branch which you want to merge in. So what is happening here? For example, you want to in the branch master, you want to merge branch ISS53. It is possible, but it will create a new commit, so-called merge commit, which will have 2 parents: former tip of master branch and current tip of ISS53 branch. And as in the previous case, in fast forward, those branches were identical. In this case, not fast forward, those branches are not the same, they're not identical, and they differ presumably by content of commit C4. Okay, so now what we want to do is to discuss collaboration via GitHub. So we are now in directory playground. It contains a project called word counter. Let's go to this project. It contains 2 files, which is one of them is a simple word counting Python program. You don't have to know Python for that. If you do, it is kind of additional plus, but you should understand that Git doesn't care about the programming language at all. It considers every file as a text and nothing else. I just wanted to have something like meaningful there. And we have a sample text here, just piece of text, a small novel by Henry. And the program works. It counts letters, words, and paragraphs in the text. Now, we start our project, and we made an empty Git repository in it. We say to Git who we are, added a useful alias called graph, just for us to show nicely decorated history. And we separate into commits. So first I do staging, then committing. And again, I add and I staged sample text and committed. And now our history contains 2 commits. And our head points to our master branch, and we don't have any other branches. Now, Git remote repository can be either a Git server, like GitHub or GitLab or Bitbucket or Gerrit, or actually any machine with secure shell access. And if any machine you can remotely log in, you can make a Git remote repository there. So Git is decentralized and strictly speaking, doesn't need to have the repository. Every repository is the same. This repository on my local machine, if I want, can function for someone as cloud or remote repository. Or even different directory on your own machine can be a remote repository from the point of view of Git. Okay, so to start working with Git on GitHub, first we have to set up a GitHub remote repository. So one would create an account if it's not yet created. Then click a button, create new repository. Then configure the remote, it's called remote. It's kind of a reference to the remote repository in your local repository. We will do this in a minute. And then push the master branch or rename the branch to main to the remote repository. I suspect that the pictures might be too small for you to see on your Zoom screens. It depends on your resolution. But we will just do it for you. Okay, so I go to already registered account. Am I still sharing my screen? Do you see a new web page, which I just opened? Yes, okay, thank you. Okay, now, and I create a new repository. I'll call it, say, word counter. I make it public. And I create it. Here we are. Now we have a screen to give access or quick setup. There are 2 kinds of access. One is HTTPS access, another is SSH access. So secure HTTP and secure shell. We will work today with secure shell. I will talk about it in just a moment. So if you switch between HTTPS or SSH, GitHub just gives you different instructions, slightly different instructions. So we do SSH, and we pretty much will follow these instructions. Push existing repository from the command line. Okay, let's switch back to our Jupyter notebook. And we start with adding, so git remote add. Name of the remote repository, traditionally it's origin, but we will call it GitHub. And this link, which was provided to us by GitHub. Now we have git remote -v lists all remote repositories, all remotes. We have a remote called GitHub, and the same URL is basically used for fetching and for pushing. Then, as GitHub recommends nowadays, we will remain our master branch to main. Why not? And git branch -v shows in a verbose format our current branches. So we have branch main, and the latest commit on it, we added the sample text. Now let's try, as instructed, push it to GitHub. Is instructed where? Here. Notice that instead of origin, I'm using the word GitHub because I just name my remote GitHub. git push minus u GitHub main. And we have an error. Why? Because GitHub has no way to know that the person who just pushed, it is the same person who just logged into GitHub. We have to set up GitHub credentials. So GitHub supports at least two types of credentials. It is secure HTTP, and corresponding URLs look like HTTPS / your name at github.com, your name like name of your GitHub name, and then path to your repository. Then you would have to generate an access key on the GitHub site and download it. And handling differs to an extent on different systems. On Windows, on Mac, and on Unix, the handling of HTTP access uses slightly different utilities. We will use secure shell access. It requires a secure shell client, but it is ubiquitous in Unix world, and it packaged with Git when you install Git on other system, both on Mac and on Windows. Actually, it is pre-installed on Mac also. So only Windows needs it as a separate installation, and it is packaged with Git. And it actually has other users. Git just reused in existing infrastructure. But it requires generating what is called a private public key pair. And we generate it on our local machine, and then we upload it to GitHub. Yeah, and these ways are not mutually exclusive. You can access the same repository both ways. So first we have to generate our key pair. SSH kgin key generator is the command for it. It has quite a lot of options. So here I am creating a SSH kgin. Type of the key is this. It is kind of what cryptographic algorithm is used. This is one which is nowadays recommended by GitHub. Here there would be password. Is because of the limitation of GPython notebook, I am leaving the password empty. So in principle, anybody who has physical access to my computer can pretend to be me without knowing password. But for that, this person would have to have access to my computer, which by itself password protected. So it is not as unsafe as it might look. Then I'm telling what is my email, and finally where I want to save the key. Okay, the key is generated, and now we can list the content of the directory, and we have two files. So this is private part of the key, private key. It is secret, it is protected by the password normally, and you are not supposed to share it with anyone ever. And this is a public key. It is public. You upload it to GitHub. You can share it with anybody and any, say, remote system to which you want to be able to log in. It is not secret. Now, we have to copy-paste the public key to GitHub. And for that, first we just print it on the screen. It's actually quite short. And then we have to go to your GitHub profile, settings, and SSH and GPG keys. So I'm going to GitHub profile. Sorry. GitHub profile. Missing it. Sometimes it's difficult to find anything here. I simply put settings here. Yeah. And I find here SSH and GPG keys. Yes, yeah. It is old key. I don't need it. Then I say new SSH key. I say temporary workshop key or any other sensible name. And then I am copying this and pasting it here. It asks me for my GitHub password, just to make sure that it is me. And now we have the key available. Okay, now what? Now we start something which is called SSH agent. Again, many operating systems started it automatically, but here I am doing it deliberately from a clean slate. And then I add the key to this agent by name. Normally it would ask password of the key here, but our key is without password right now. And then I try to pretend that GitHub, it is just yet another remote system, and I'm trying to log in into it using Secure Shell. Git tells me that I'm authenticated successfully, so my SSH access works, but GitHub is not a remote system for shell access, and GitHub tells me about it. This is just a test that everything works. Okay, so now let's push again. And we successfully pushed our main branch to GitHub. Under the hood, Git asked the SSH agent about necessary credentials, provided them to GitHub, and GitHub accepted them. Now we can check adding -a means all, and -v means verbose, all branches, and we see a new branch, which starts with remotes, GitHub main. It means that there is a branch which is called main, and it is branch which tracks a branch main on GitHub. We can see content of our repository, and we see we have word counter and our files are there. Now let's edit a repository, but not locally, but edit remote repository. Say we can add a README file, as GitHub recommends. Word counter, a toy Python project. Put a commit message and commit. So pretty much whatever we're doing from command file, you can do through the web interface of GitHub. The only challenge will be to upload the files, so to say. So, but while it is minor edits, like here, I can do it directly through the web interface. Okay, so we did some changes. We now have README. But our local repository has no knowledge about it, of course. Still, our current status, it is edit a sample text. So we can fetch changes from the remote. So it is one of the few network operations. So first one we knew is a push. Push is a network operation, and fetch is a counterpart. So after fetching, we can again verify our branches and see that our main branch is now behind by one commit from the remote branch, and remote branch has the latest commit with README created. Now we can merge the remote tracking branch into our current branch. It's a fast forward merge, and we saw that now if you put git graph, you see that we have all three commits in the history. Both main and GitHub main points to the latest commit, and we can verify that README file is indeed there with its content. Now let's make another change in README. Let's add something like words and paragraphs and just to be more consistent with the rest of the tutorial, I am a little bit thinking about what should be the message. Counts words, paragraphs, and letters, for example. And updated README, any changes? Then we can use, instead of git fetch and then git merge, we can say git pull. Pull used more often, like in the same pull the change, because it automatically merges. So pretty much pull it is the same as a fetch followed by merge. So we don't have to do explicit merge. And we see that README is updated and our local repository is aware of this. Okay. Now, so if something happens with my computer, say hard drive is broken, the copy of my repository now lives in GitHub. But what about collaboration? So you can designate a special close collaborators. For example, yourself from the other computer. You can push to the same repository. Or you can, in GitHub configuration to the repository, say that this and that GitHub user is my close collaborator and also has a right to push to that repository. But it is impractical to give the whole world rights to push to your repository. You want to vet those pushes. But on the other hand, if repository is public, you want to have useful feedback from your users, and the best feedback is a contributed code. So let's put a contributor head. I should have really had a head with me. Do not think about it. And so now I am a contributor. So I then go to GitHub. Find this interesting repository and say I want to contribute to it. For that, I fork it. I press this button, fork. Here we are. So it is exact copy of the original repository, but GitHub knows it is forked. You see, it says forked from there and there, but username is mine as a contributor username. Okay. Now the contributor goes to his or her computer and then clones. How do you know how to clone? Well, if I go here, GitHub tells me how to clone. What is the cloning URL? Here it is. I can clone over HTTPS. I can clone over SSH. We're using SSH today. So I just have to use this URL. I could say just git clone and that URL, that it would automatically create a directory called word counter. But because we already have this directory, I give an alternative name, word counter clone. Now, if you see, we have now word counter and word counter clone. I am working as a contributor on the clone. It has the same files. And automatically, GitHub created a remote called origin originally this where we cloned from. We rename this remote to GitHub. And suppose I want to improve this project. For example, right now, if I just start wcount word count, it gives me error rather than sensible usage information. So I want to improve it. For that, again, I'm a contributor. I'm telling that Git that I'm a contributor. Now, I don't want to change the main branch. I want to delineate this is the upstream, kind of the original code, and this is my features which I added. So I check out a new feature, create a new branch. So new branch can be created and checked out simultaneously using git checkout -b. Now, if we see, we have branches main and help feature is the commit branch, and it is actually the same commit. Now let's edit our counter file, and this is the changes needed to make us useful help message. Again, believe me, you don't have to know Python. We edited file, we check what is the changes, we verify that it indeed works. Important step. We will deliberately forget it later. And once it works, we commit it. Again, we should end first stage, then commit, but I do a shortcut. I say commit, add message, and I set .meets current directory. I commit whatever files can be committed in the current directory. So it automatically stages and commits. And you see, we have as a contributor a new commit. Now let's push it to the repository, back up there to the GitHub. So git push where to, what to push. Okay, so a new branch created, and Git, or as a GitHub through Git, helpfully told us that, well, if you press this link, you can create a pull request. Well, let's do it. So now we as a contributor say edit usage message and comment. Hi. And create pull request. Now I am again wearing the hat of original author. I am not a contributor anymore. I am back the original owner of the repository. I am going to my repository. And I see there is one pull request. Okay. Oh, there is an open pull request, edit usage message. I'm keeping on it, pressing on it, clicking, hi, edit usage message by your program. I can actually even verify the changes. Well, looks good. I say merge pull request. Then give some little bit pull request from Galaxy test. Edit usage message. It will be my merge commit message. Now, pull request is merged. Now, let's put contributor head again. Now I'm a contributor. I go to my directory and I actually add yet another remote and I call it upstream. And this is remote is original, where I forked from. I fetch it. I check my branches. I see graph, and yes, I see that upstream just merged my pull request. Well, that means it's time for me to update my main branch. Contributors main branch. I checked out main branch. I pull main branch from upstream. I verify that now my main branch contains my merged PR. I can verify that help feature branch is actually merged, and I can just delete it. I'm done with this because my help feature is integrated into upstream. Delete it. Push just to synchronize. Back to my contributor repository, and if I visit my contributors repository, it says this branch is even with the original. And last commit 2 minutes ago, it is by PR, pull request, added usage message. Well, I can verify that Git agrees with me. Now, I am not a contributor. I am original author. I go back to my word counter. Synchronize. Important. I have to, from time to time, remember to synchronize my state of the local repository with the remote repository. No harm is doing it twice. Suppose I do it again. Already up to date, nothing to change. Good. But suppose I didn't do it. Suppose somebody came, or me myself from different machine, and modified something. Say reflected our latest change in README. I am editing it. Something like that. Run without arguments. Long usage. Okay. Any changes? Okay. Meantime, I decided to improve my program and say I don't want to count spaces as letters. So I'm editing the file. Make sure that I count letters only within words. You know, it was 15,000 something letters. Now it's 12,000 something letters. So changes are git diff. What did I change? I just moved some lines, removed the line from here, added line to here. I added commit message, count letters and not spaces. Fine, our directory is clean. we can push, and we got rejected. Why? Well, updates were rejected because the remote contains work that you do not have locally. This is usually caused by another repository pushing to the same ref, which is what happened, because we changed something behind the scenes on another machine. Let's look at this in more details. So let's fetch current situation on GitHub and see the graph. So this is where GitHub is, this commit. This is where our local branch is, this commit. They have common ancestor, but one is not descendant of another. So the tip of the current branch is not a direct ancestor of the remote branch. No, it is actually the other way around. It's not a direct descendant. I'm confusing descendant and ancestors all the time. I'm sorry. Okay, so anyway, let's just fix this. How? Well, we have to pull from the remote repository. We didn't do it before making our changes. Now we do it. But remember that now it is not a fast forward commit because our history diverged. Our history diverged. That means there will be merge commit from remote to us. And therefore conflicts are possible. But there were no conflicts. Merge made by recursive strategy successfully. This is verify what is happening. Now look at this. Our current branch is a direct descendant of remote branch. And so when we push, it will be fast forward on the remote side. So remote branch will simply position from here to here. Okay, we push successfully. We can expect and check our commits there through the web interface. Here they are, including the latest merge commit. Updated readme how to get help, count letters, not spaces, and merge commit. And Git also agrees for it, including and shows all merges. You see, merges, especially if there are no conflicts, usually don't provide much information. Some people consider it as a drawback of Git. It has all these merge commits, which the only thing they say it is, oh, there was a merge. So if you don't like to see them, you can specifically say that I want to see history without merges. But there is a way to avoid merges altogether, and we will discuss it later today if we have time. Okay, this is pretty much what I wanted to say about remote collaborations. So, once again, I showed how to push your repository to GitHub, how to pull your repository or somebody else's repository from GitHub, how to contribute, how to do pull request, and how to accept somebody else's pull request. I suggest that if you have questions, ask now. After that, we will have a short break, maybe 5 minutes. And I will go to the second part, how to recover from mishaps. Somehow the second part is a little bit larger just because there are a little bit more mishaps possible. Okay, any questions? Am I too fast? Am I too slow?
So, Alex, the one question.
Uh-huh.
So the examples you are showing here is like using this command line.
Mm-hmm.
Is it applicable for any operating systems, or this is for the Linux?
Okay, good question. So it is one of the reasons why I chose command line. Command line is pretty universal. So if you install Git for Windows, and if you install Git for Mac, you will be able to do pretty much the same commands from the command line of Windows or Mac. Mac, you just run terminal, and in Windows with Git you get something which is called Git Bash. It is shell, like interactive shell, command line shell, which behaves more or less like Unix shell, and not like Windows cmd.exe shell. And therefore, you can transplant your Unix experience into Git Bash in Windows one-to-one. However, of course, you don't have to work with the command line all the time, and various IDEs, integrated development environments, for example, RStudio, provide graphical interface to Git. And there are third-party graphical Gits. I think in Windows it's called desktop Git, something like that. Under the hood, it is still the same Git commands. That's why if you know Git commands, you will realize that, when I press this button, what is happening and behind is Git commit. And if you get message back, something like, after you press button, push it, you said something like, your push is rejected, you know what to do. And I noticed that usually graphical interfaces are subset of command line interfaces. Quite often, I say that, no, I don't trust IDE. It cannot do what I wanted to do. So I closed IDE and I switched, even sometimes I don't have to close. I switch to command line and I do some recovery operation, usually recovery operation. Because basics are very well implemented. This cycle, pull, edit, commit, push, I implemented very well using IDEs. But, and I usually do it from IDE, not from command line. But if something is messed up, switch to command line is very useful.
Okay, thank you.
Okay, so 5 minutes break. I don't want to throw anybody in the guest room back, but we can probably pause the recording. I think. Okay, so we continue. So next part is what to do when you experienced any mishaps. So let me again start sharing my screen. Okay, do you see it? Okay. So let's again do some housekeeping. Okay. Now, so usually Git is very forgiving. If a file is at all tracked by Git, you can recover it. You can undo almost any Git operation, but careful. Some of the operations which you cannot undo, it is those undos. Some of the commands, some of these recovery commands, they what is called colloquially rewriting history. But it is not rewriting history, it is like in 1984. They just create alternative fictional timeline, or real timeline. But do not use history rewriting commands ever if this history is already shared. In other words, if you pushed a commit, you are not allowed to rewrite history prior to that commit. Okay, so let's consider something which is not actually a mistake, raise a minor annoyance. But suppose you are busy working on implementing certain feature, then the work changed some of the files you're working on because somebody else's work changed some files you're working on, and now either you have to commit your work, deal with the rejected push, which is not a big deal, but once you push rejected, you have to pull. Of course, you don't have to wait till your push is rejected to pull. But anyway, once you pull, you create a merge commit, and you might need to resolve conflicts. well, sometimes it is more convenient to put your development away temporarily, pull the changes, reintegrate the changes, avoiding merge commit, and still conflicts might be needed to be resolved. And then, because the history is streamlined, your push will not be rejected. So you can use either approach A or approach B. We will consider like more streamlining approach B. So suppose someone modified README file remote. Let's do it. So somebody introduced a new feature. Modify this file. I just want to demonstrate something right now. Look, grid commit summaries contain fewer than 50 characters. If you have something else to say, put it here. I deliberately was verbose here. I will put this. Commit changes. Okay. Meantime, we are working on a new feature. Say not count empty paragraphs. Then we added the description. Okay, so another thing to understand, in real life, what will happen here, an editor will pop up. That, again, because of the limitation of Jupyter notebook, I am editing right in the Jupyter. Okay. Then we edit the file. Basically, if it is not paragraph, we don't count it. This is our change. And now we just learned, oh, somebody's changed sends upstream. So we don't even commit our work, we just pull. Well, Git doesn't pull. Why? Because we changed README and have not yet committed. So Git cannot do merge commit, but because our changes are not yet committed. But if those changes would be just blindly taken, that our local change would have been overwritten. So please commit the changes or stash them before you merge. Well, we decide to stash. So what is our situation? We have two files modified and not yet staged. Well, we can stash. We can check. Yes, we have one file on stash. Now we don't have any modified files. where they are. Well, they're inside the stash. They're stashed away. So we can pull again. So technically we just pull, so we can just merge. But usually we can just pulling is faster. Well, fast forward, no problem. README updated. This is our main branch, just synchronized with GitHub, with upstream. But where are our changes? They're here. They're stashed away in the separate commits. We can check that they're there. Just for the purpose of demonstration, let's add some other temporary file. We have its file untracked. We make it, we track it. Here's some other file. We can stash it too. It disappeared. And we can see that we have two stashes now. We don't actually need this some of the file, so I'm going to drop the stop stash. So I'm dropping it, but our important stash is still there. Now let's pop the stash. So this is drop. Drop stash is irreversible. We got rid of it. But pop stash means we are trying to restore the stash and reconcile it. It may cause conflict. In a previous run of this notebook, as you see below, there was indeed conflict. Let me check. Yes, indeed there is a conflict. And why? Well, upstream was updated. This, and our stash change is this. We have to reconcile them. Well, it's easy. This is our reconciled file. Save it. We still have this stash list because if there were no conflicts, it would be dropped automatically. Well, because there were conflicts, we drop it manually. Check that changes make sense. We have modified committed changes and still unmerged, but by explicitly committing them, let's play nicely. Yes. So by explicitly adding, I told Git that I resolved whatever conflicts was there. Okay. Git status shows that we have empty clean working directory, and now we can push. And we pushed our change reconciled with upstream changes without any merge commits. So if you shows it, updated README upstream, and then do not count empty paragraphs updated by us. There is no merge here. Okay, so now suppose my wonderful cat walked on a keyboard when I was working on this. So suppose I have a file, and that cat comes and does this, and I haven't noticed it. But before coming and pushing or committing, I said, oh, my README file is modified. And which way? Oh, there is some nonsense here. In principle, I can just look at the modification and revert them manually. But if the file, if I was not, if file was freshly committed or pulled from repository, checked out from repository, I can simply check out undamaged version from repository again. I said git checkout. I check out by default from the head, so from the current version, latest committed version. Dash dash just means that options to the command are over. Now file name is started. So, and now file is like new. No changes, status clean. But be careful. This you are saying that I don't care about current content of my file. I am checking out whatever I last committed. So if there were useful changes, not only cat changes, they are lost. Okay. Just to make sure that we didn't change anything. Okay. Now, sometimes you need to amend a commit. You forgot to stage a file, for example, or you found a typo in your commit message. It's similar to unsending a mail in, say, Google, in Gmail, or in your local mail client, doesn't matter. Until you actually press the send button away, you still change it. You can still change it, even if you committed it. So suppose we want to change something like the program does not count empty parameters. Not much change. We say as much. I'm sorry. Here's our commit. And then we look at the history and saying that nothing much is not very good commit message. Not very descriptive. So let's amend it. So what should we do for that? We just say git commit dash dash amend and give alternative message. And lo and behold, nothing much changed to minor English corrections. But look at this. This commit ID was ended as 2277. This commit ID is C93A. It is a different commit. We replaced one commit with another together with a message, and we basically rewrote the history. Actually, we can still recover the forgotten commit if we happen to remember its commit ID somehow, just as a curiosity. Here it is. But you see, it is not accessible from any branch by ancestral chain. It's not accessible from head, down, 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 down. It's not accessible from GitHub main, nothing. So sooner or later, it will be garbage collected by Git. It is a dead-end history. So suppose, let me change it for clarity. Every time I do it, commit IDs are different. They're cryptographically strong. So that's why different every time. Okay. Now, suppose you forgot to stage a file. Say you decided to add installation instructions. This file is untracked. You made it tracked. New file. You edit the file. You add words. No special installation is required. And you forgot to stage it again. So you committed it, committed whatever was currently to be committed. And you see that you have modified changes of the commit, modified files. Well, you can see what you forgot to commit. This. Well, that easy, just added, let's stage those changes. Now you see your file is to be committed. And then you commit it again, but telling that you want to amend the previous commit. And you are fine with the previous message, so you don't want to change it. You just forgot to add installation instructions, now you actually add them. Commits are still there. And here, edit installation instructions. Okay. Так, what is our time? Sometimes, for this or that reason, commit might end in a wrong branch. For example, an abandoned branch. Or sometimes you just forgot to switch branches. So let's start another branch where we want to do two changes. You don't want to count words which consist only of punctuations, such as dashes, because they're not words. And you want to report some statistics about the text. So first one is easy to implement. We're just adding that if all characters are actually punctuation, we just don't count the word. Fine. We check that it works. I mean, in a proper project, we will have a test files to check whether that it indeed works. We verified our changes. We add commit message. Now we start working on the second feature. Added so far a placeholder help message that sooner or later there will be statistics in this program, but it's not yet implemented. For example, check that it works under certain definition of works. Committed it. And you see that doesn't contain the paragraph and it calculates statistics. Okay, that is outdated, we don't need it. Yes. Updated readme. And now your boss comes and says, no, statistics is too much work. And why anybody needs statistics? But not counting non-words, good idea. So you abandon the branch. But you still want to save your work, at least about counting. So you check out to the main branch. You look at the graph. Here's our another branch. But we want to preserve this count only real words. Commit. We can cherry pick it into our main branch. So now we are on the main branch. And we can either use the commit ID, but we notice that it is 1, 2 commits up, or down, how to say, 2 commits from the another branch. So we say exactly this. We cherry pick from another branch, but 2 commits back. It automatically cherry picks and commits. Here we have the same commit here and here on different branches, and they have different commit IDs as they should. Commit ID is unique. Okay. Now we want also save our work on README file, but we cannot just cherry pick it like that because it describes also statistics, and statistics is not implemented. So we cherry pick the tip of another branch. Why? Because it is where we updated README. It is exactly another branch. We could use commit ID, but I'm just telling that it is the same as another. But I am telling that do not commit it right away. So if I say git status, after that we see that it is changed, it is staged for commit, but not yet committed. So we can change it. Here I conflate with that kind of simultaneously show another situation, similar. So suppose we commit, we staged for commit a file and then decided we don't want it to be staged for whatever reason. Then we can use git reset. It actually says this. So git reset head and the file to unstage. Well, by default, we unstage all the changes. So now the file is still modified, but not staged for commit. We can edit it. Yeah, and actually I forgot to mention that it doesn't count empty paragraphs or punctuation only words. It was a mistake in the description. But the important that we don't need statistics. Then we actually I can change it slightly more. Sorry, let's change it again. You see, until I commit it, I can change file as much as I want. Okay, changes are fine. Update README. And here we are. So on the main branch, we have updated README and count only real words. Then we don't need another branch. We decided to abandon it. Suppose. So here is two branches. We remove the branch. Git asks us, are you sure? You haven't merged that branch. No, I'm sure. I'm very upset on my boss who said that I should abandon this kind of cool feature. And I am removing branch. -d means, yes, I do mean it to delete it. Git gives a hint how to do it. Git graph. Now I want still to introduce new features. I'm adding here some bragging about it. Okay, so then I add README, add commit telling that I advertise features in README. But then you decide two things. First, actually skipping of non-words. It is a good feature. It's a new feature, so let's put it back to the feature branch. And second, your latest commit, my latest commit here, is really not needed. I had a second thought of it. So, what is the current situation? We have this commit which we don't want. And we have these two commits we should actually belong to this branch. And they belong to main branch instead. So what we want to do? We want to move new features branch to this commit, and we want to move the main branch to this commit before I started introduced new features. Okay, so for this we use something which is called hard reset. It is destructive operation. It is very destructive operation, in a sense that it just forcibly sets the content of your working directory, all tracked files, as if you just had a fresh checkout. It is usually like almost last resort. I don't know what I did with my Git repository. I'm very confused. Okay, I could, in principle, remove directory and then check it out again, say clone it again from the remote repository. But instead, I am just using hard reset on the certain commit. So I am resetting my current branch to the commit one above current head. The tilde means one above. And look, advertise features commit disappeared. My head now is on count only real words, and both new features in main as there. Now I switch to the main branch, and then I again hard set up the current branch to commits back. Sorry, I'm looking at the wrong page here. I want to set up main branch to commits back before I started added new features. Here we are. Notice that because branch new features were still pointing on that commit, we still see it. It's reachable. So now new features branch points to here to updated readme and counting real words, and main branch points to kind of standard things which doesn't have extra features. Now, suppose we want to add a new feature, like a lorem ipsum text. Okay. Well, git add lorem ipsum, it's a new feature, add the 2-paragraph lorem ipsum text sample. Notice it's a new file, so I have to explicitly stage it, because if I just say commit whatever is there in the current directory, it will not pick it up because it is not yet tracked file. So I have to add it explicitly to make git to track it. But after that, git commit -m dot means current directory, and it will commit all files which are tracked in a current directory. Okay, now I am running it, and then I see an anomaly. Wait a minute. So these 2 paragraphs are identical, but the difference that it has 3 dashes here, like a long dash. So because our program has a new feature to not count the non-words, we should have, and paragraphs are identical. Well, they are identical. Otherwise, it should give us at least even number of words, actually 50 in each paragraph. But it had 101. What happened? What's happened with our cool feature of not counting non-words? We committed to the wrong branch. We were working on main branch, and then committed new feature to the wrong branch. So we want to reset the branch, but we don't want to lose this work. So we check that our working directory is clean. What we want to reset main branch 1 commit back. One commit back here. but preserve whatever we change there. It is soft reset, not as dangerous. Okay, now main branch is where we want it to be. We are on branch main, and this file is staged but not committed. So then we switch to the new features branch and commit it. Okay, so Laura Gibson text, sample text is exactly where we want it in a new features branch, which is our current branch, and everything works as expected. 100%, 101. Okay. But then we had a second thought. We convinced our boss that no, statistics was actually a good idea. It's a new feature. So we want to recover and finish statistic computation. But we deleted this branch long ago. If you look in the graph, there is nowhere it is mentioned. It's lost. But if it happened only recently and Git garbage collector have not yet run, we probably can recover it. What does it mean recently? I think that unless you specifically tell it, Git garbage collector goes on every several days. I think something like 2 weeks. Also, you can specifically say git gc, and then it will run garbage collector then and there. But then you would lose all your, forgotten history. Okay, git reflog. Can you spot where we do something about statistics? Here. Start implement a statistical analysis. Yet another point of a descriptive commit messages. If I would say just update, 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 I would never know that it's a commit which I need. So commit, which is called head at 14, it is what we want. Well, let's check it out. So let's check out it. Now we enter it into something which is a little bit scarily called detached head. So first we verify that our stat feature is kind of back. And if we analyze the graph, we see that this statistical analysis is there. Head is set in this commit, but the head doesn't point to any branch. The head points to a commit. And git branch tells it head detached this and this. Inspired by this metaphor, classic programming paintings said that this is the picture about detached head state. Actually, it's not as scary as it sounds. We just want to make a branch. And now this commit also has a branch pointing to it. Then check out back our new features branch. So again, head now points to new features, but now that forgotten commit and its history is available as a stat branch. We could cherry pick from that branch, or we can just simply merge this branch. We don't have to change the message, that's why I said no edit. And we see that started implement statistical analysis now merged in our new features branch. So stat branch is merged, so we can safely remove it. Fine. Так, okay, what's the time? 16:38. Okay. Let me check. Okay, so suppose next thing is suppose you accidentally added the file. So you started your nodes, then you changed readme, saying that say a few sample files included. Okay, then you added whatever is in the current directory without much thinking. Updated readme, and what you mean, like two files change, whatever, but you know that your file, my nodes, is not tracked. You just verify it, or nothing to commit working directory 3. So you accidentally added my nodes. Then you see, oh, two files changed instead of one. We want to remove the nodes from the following repo commits. Sometimes also happens that, yeah, we basically decide to remove the file. It will still be in history. History is forever. But you just don't want it to be tracked in the repository by Git. So you can say git rm. Git rm actually removes the file. But if you say -- cached, it will remove it only from staging and from the tracking notion. It will not remove it actually from the disk. So the file is still there. You can prove it. Yes, my nodes are still there. And if you say git status, it is deleted from the repository, but still there, simply untracked. And you make a corresponding commit. You just remove the nodes. Okay. Now suppose you made a commit, but you already pushed it, and only then noticed that something is wrong. Say you decide to add, well, this long promised statistics feature, say computing average word length. You started implementing this feature. Here it is, here is the implementation. Average word length is just number of letters divided by number of words. Print average word length. Trivial change, right? You commit. You push this new features upstream. To GitHub. Then you said, wait a minute, maybe I should test it before pushing, you know. Should have. Because instead of average word length, it prints something strange. But you just push the program. Sometimes it happens in production. So you might panic a little bit. And let's amend this commit. Let's remove whatever we added. We will figure out later what's going on. Just comment it out. Okay, kind of works. Add, commit, push. Push rejected. Why? Because you rewrote history. And if you look at the graph, you will see that you already pushed your commit outside to GitHub and then amended it. So in this point, the history diverged. And you cannot push. But if you pull, you will get your erroneous changes back. So you have to somehow eliminate those. But first, let's get rid of our amended commit because it didn't work anyway. We couldn't push it. So I am resetting my repository hard to current status on GitHub. We see that we are where we were before. There's some misimplemented statistics here. It's not commented out. Now we do things in a civil way. We revert the commit. So if I say git revert, it will create a commit which basically changes back whatever was changed in that commit. So in this case, a commit is a tip of my current branch, which is called head. So basically, this means revert my latest commit. What's the difference between amending and reverting? Amending rewrites history. Reverting makes a new point in history, but with opposite changes. I say no edit because I'm fine here with the default automatic commit message, which is revert and then the commit message. So if you see the status and then graph, you will see that we have commit, which is called revert this, and we can push now without problems. Okay, fine. Upstream is saved. Nobody is going to use our half-baked feature accidentally. Now, we have time to think. First, we want to figure out what commits ever touched this file at all. So we can just the same do git graph. Reminder, git graph, it is just fancy git log. It's git log with a lot of arguments. So whatever works for git graph works for git log. So git graph, and I mention specific file. So this is only those commits which were touching that file. Well, and I think what's wrong, it is this commit. Okay, let's check out that commit. So I said git check out what commit I want to check out the file from. So it's different from git reset. I am preparing a new commit, but for that I pulled a file from my history. So again, history is forever. I took a file, wcount, and I say I want wcount as it was when it was in commit number so and so. Here it is. We can edit it. And after some deliberation, we notice that there is a minor error. And the error is we forgot F formatted string here. Again, if you don't know Python, don't worry. What was forgotten is this F. Okay. I do changes. I verify that the change is actually there and nothing else I changed. I verify now that it works as expected. And I create a commit. Saying that it's fixed, so look at the history. Added average work length, then reverted, then fixed. And then I'm pushing it to GitHub, and everything works. Так, just a few moments, sorry. Okay. In the last few minutes, we will talk about something which is called rebasing, streamlining the history. The idea that you can rewrite your history in such a way to pretend that there were no mergers. Reasons for that are mostly aesthetical. Also, can be different ones, but in my opinion, not very authoritative, it's aesthetical. So, say, what does it mean aesthetical? Some repositories, some research groups say that we don't want any confusing branching and merging in our repository. Users of our code got confused what they should pull, and we don't want our history cluttered by non-informative merging. So you can branch and merge and branch and merge as much as you want, but then before pushing to our official repository, you rebase everything, streamlining the history. It is possible. It is history rewriting. So because it's history rewriting, should not be done after you pushed, but it can be done before you pushed. So how rebasing work? Suppose you have two branches diverged at some point, local and upstream. So when you do rebase, so first, like long story short, you can read the slides later, but long story short, first, if you rebase local on top of upstream by using git rebase upstream local, it basically means pretend that there was first upstream and then local, which means find the common ancestor, then use only upstream branch and put local branch at the upstream, and then replace those local commits on top of upstream. So basically, in a way, transplant local commits from here to here, from here to here. One can imagine the multiple cherry pick, as if I cherry picked all commits from here and then abandoned this branch. Okay, so now remember that git pull, it is normally fetch and then merge. But if I say git pull minus r dash r, it will be fetch and rebase instead of merge. So imagine that upstream here, it is well really upstream. It is the changes in GitHub repository. So instead of merging upstream changes inside my local commits, I temporarily forget my local commits, I pull upstream changes, and then I put my local commits on top. So basically, it is as if I, well, what to say? As if all the changes which are there already done concurrently with me were made before I started working. And then I pulled, and then I applied my changes on top. So let's see it. Let's change a remote file repository. So it's some useful message. So some changes. Okay. Then let's count, let's change in related file locally. Basically, I do this every statistics only if user requested it. So I said that stats is now implemented, and if I really want to do it, average want is printed. Let's check it works. It works. Git commit to statistics on demand. Git push. Push is rejected because, well, somebody did readme changes. Well, if I want to pull the remote but insist on the enforced forward, it will not work. So, in other words, if you didn't know whether something is changed or not, and you want to pull changes from upstream, but you don't want to accidentally create merge commit, you can say that you want fast forward only. And if it is not possible, Git will tell you this. Well, why? Well, for the same reason as usual. We do statistic on demand here, but readme was updated there. So we want to replace this updated readme changes on top. Or the other way around. We want our statistics to be updated here. So we can and you see git pull -r worked, and our history is streamlined. It's okay to do this because this rebase happened before we push. Now we can push our rebase history back. Okay, and the last one, general speaking, is this. So some general do's and don'ts. So again, make commit messages concise. 50 characters is the golden rule. Avoid stating the obvious in your commit messages because Git log can provide it anyway. So you don't say what file changes. I edited greeting file. I can use Git log with certain options and get what files were changed in that commit. The same thing, I can go using Git log and figure out what were the actual changes. But what you should state in your commit messages, it is why. For this made up example, why I replaced hello with hi. Well, I made greetings less fun. And never ever rewrite published history. So do not amend pushed commits. Do not rebase already pushed part of a branch. And none of them, if you do it, any of them, the Git will reject your push. But you can do something which is called force push. Don't, unless you really know what you're doing, because it creates a lot of problems for people who might have already copied your work. Okay, so there's a URL with the most used Git commands. It's a nice cheat sheet. And if you have any questions, send me email or ask now.
So thanks, Alex. Are you going to share this slide with us?
Yes, I sent URL some time ago. Так. Aha, okay, I see a question. So first question answered. Yes, the slides will be shared. I sent a link some time ago, and those files will be uploaded there. Previous version of the slides is already uploaded. So I have a question here in the chat. So Jupyter Lab on macOS, for example, when I write, why I don't have to put exclamation mark? I can demonstrate this. So what is difference here? It is not a Python notebook. It is Callisto Bash notebook. Moreover, it's a Callisto Bash with my local changes to adapt for this workshop. I will push those changes to Callisto Bash Git repository sooner or later. So normally you do it in those commands in terminal. For example, here. But also you can do it from a Python notebook. New Python notebook. So it's a Python. So if I say Git, Git is not a Python command, but I say exclamation mark Git. That means I want to pass it to the shell. But again, because it's a Python notebook, the notebook I was presenting today is not Python notebook, it's Callisto Bash notebook. That's why I was able to do what I was doing. Okay, any other questions? Apparently no. So feel free to send me email, you know my email address. I hope anyways it can be distributed. And thank you very much for your attention. Have a good day.